Hello, in this video we will learn about how to use pointers for dynamic memory allocation. So array is a collection of a fixed number of values as we have already discussed, and once we declare an array we cannot change the size of it. But sometimes the size of the array you declared may be insufficient. In order to solve this issue, you can allocate memory manually during runtime, and this process is known as dynamic memory allocation. For dynamic memory allocation, the library functions are malloc, calloc, free, realloc, and all these functions are defined in the stdlib.h header file. Now let's discuss about each of these functions. So first is malloc, which stands for memory allocation. The malloc function reserves a block of memory of the specified number of bytes. It turns a pointer or void which can be casted into pointers of any form. Now the syntax is ptr followed by cast type of the pointer, then followed by malloc and size. Now let's look at the example. ptr equals to float star malloc 100 into size of float. Now this statement allocates 400 bytes of memory because the size of float is 4 bytes, and the pointer ptr holds the address of the first byte of the allocated memory. Also, the expression will result in a null pointer if the memory cannot be allocated. Next is calloc, which stands for contiguous allocation. The malloc function allocates memory and leaves the memory uninitialized, whereas the calloc function allocates memory and initializes all bits to 0. The syntax is ptr followed by cast type calloc n, size. Now here in this example is ptr equals to float star calloc 25, size of float. This statement allocates contiguous space in memory for 25 elements of type float. Next is free. Dynamically allocated memory created with either calloc or malloc doesn't get freed on their own. We need to use the freed function explicitly to release the space. The syntax is free ptr. Now let us look at a code to understand the working of the malloc, calloc and the free functions properly. So in this code we are calculating the sum of n numbers entered by the user. So first n is the number of elements that we are entering, and we are using the malloc function to dynamically allocate memory for the number of elements we will enter. If memory cannot be allocated, it will run this if statement and print the message that memory is not allocated. If memory is allocated, then we will enter the elements, and using this for loop, the sum of the elements entered will be calculated, and the sum is displayed using the printf function. Now we need to deallocate, that is to free the memory dynamically allocated by the malloc function, and for that we use the free function. Now let's run this code. So suppose the number of elements will be 4 and we are entering 9, 6, 1, 7, and the sum is 23, which is correct. Now let us look at another code where we will use calloc function. Now this is a similar program, but instead of using malloc we are using calloc. First there we are entering the number of elements, that is n, and then using the calloc function we are dynamically allocating memory for the elements that we will enter. If the pointer is equal to null, that is memory cannot be allocated, the error message is printed. Otherwise the sum of the elements entered is calculated and the sum is displayed. And after that, in order to free the memory allocated, we are using the free function to free the memory allocated or to deallocate the memory. And then in order to free the memory dynamically allocated or to deallocate the memory, we use the free function. Now let's run this program, and suppose 3 and then 8, 1, 9, the sum is 18. As you can see, this program also runs perfectly. Now, the last function that we want to discuss is realloc, which stands for reallocation. If the dynamically allocated memory is insufficient or more than required, the size of the previously allocated memory can be changed using the realloc function. Syntax is ptr equals to realloc ptr comma x. Now let us look at an example to understand this better. Now, in this function, we are first entering the size of the memory that we want to allocate, that is n1. Then using the malloc function, we are allocating the memory dynamically, and then we are printing the addresses of the allocated memory. Now we want to change the size of the previously allocated memory, and to enter a new size, we are using this n2, and now we are using the realloc function to reallocate the memory using the new size, that is n2, and we are also printing the addresses of this newly allocated memory. And note that we are again using the free function to deallocate the memory that we have allocated dynamically. Now let's run this program. Suppose first we are entering the size to be 3, and these are the addresses of the previously allocated memory. Now we are entering the size to be 6. Note that the first 3 of both of these dynamic allocation is the same. The last 3 addresses are simply reallocated. And that's all for now. Thank you for your patient listening. Please don't forget to like, share and subscribe to our channel for further videos on this course. Thank you.